Any questions over any of the homework assignments so far? So what we're looking at today is continuing on with what we did yesterday with sine and cosine and some of the unique things we can do with it. Now the first thing we're looking at is finding the values of sine and cosine for these given angles. So the first one we can look at is sine of 62. And what we can do is we can take the calculator, type in sine of 62, and hit enter. And it'll tell us that it's 0.88294. So the value of sine at 62 degrees is 0.8, what was it? 29. Because we'll go to 4 decimal places, and since the decimal number after 9 is a 4, we round down. And that's all we have to do for this here. Now the next one, sine of 18, or sine of 14, I believe. We can go sine of 14 and hit enter. And it'll tell us that it's 0.2419. 0.24. And that's all we have to do for these here. Now if we did the same thing for cosine of 60, we would get so let's see here, cosine of, put 30, 60, is 1/2. Because we're looking at cosine this time. Which is 0.5000. And I believe sine of 60 is square root 3 over 2. And lastly, how about cosine of 31? 571, or we can just say 57 if we're going to 4 decimal places. And really what we're doing for this here is showing that each one of these do have a specific value. They actually have a number associated with them. And we can use this in solving for missing sides of a triangle. Using sine and cosine, we can solve for the missing side lengths of a triangle. Now they gave us a number here, 26. So I know that sine of 26 degrees does have a specific value because we were looking at those just a minute ago, and we know that it has a numerical value. Now sine of a given angle, as we worked with this yesterday, was equal to what over what? The opposite side length over the hypotenuse. And cosine of a given angle is equal to the adjacent side length over the hypotenuse. So if we're looking at sine of 26 degrees, it is equal to the opposite side length over the hypotenuse. Now looking at this triangle, what is the opposite side to 26 degrees? And the hypotenuse is 14. So if I'm wanting to find the opposite side from the angle, we can use sine, because sine is opposite over the hypotenuse. Now we just need to solve for the value of x. Well, what can we do to get x by itself? We can multiply by 14. And on this side here, we can also multiply by 14. And if we multiply both sides by 14, we're going to get 14 times sine of 26 degrees is equal to, well, over here we would have 14x over 14. Well, 14 and 14 would simplify, giving us just x. But what we do need to find the value of is 14 sine of 26. Well, we know sine of 26 is just a number. We just need to find out what it is. And what we can do at this point here is get the calculator and do 14 sine of 26. And hit enter. 6.137. And if we look at the directions, it wants it to the nearest tenth. So 6.1. Because the number after 1 was a 3, so we round down. And that's it. So if I'm given an angle, since we're given the angle and x is the side opposite it, and the hypotenuse, well, we know we can use sine, because sine would be opposite over the hypotenuse. Now we also need to find y. Now sine's not going to find y because sine of 26 gave us the opposite side length over the hypotenuse. So what can we use? Cosine, because cosine of 26 is going to equal, what is it? It's the adjacent over the, so the adjacent side length to 26 degrees is what? It's going to be y because 14 is the hypotenuse. 14 is going to always be the hypotenuse for this triangle here because it's opposite the right angle. The side opposite the right angle is always the hypotenuse. Now what can we do next in solving this here? Yes. Multiply both sides by 14. And on the one side, we'll get 14 cosine of 26 is equal to, well, we wrote it out on the first one and saw that the 14 and 14 would cancel out, yes? So that means over here, this 14 and 14 will cancel, leaving us with just y. So if you're solving for y, not always, because cosine is, how is it related to this angle? It is adjacent to it. Because y, if I'm solving for y, since I'm given the adjacent side to the angle and the hypotenuse, well, we would use cosine. Because cosine is what over what? Adjacent over the hypotenuse. If I'm given the side opposite the angle, it's going to be sine, because opposite and hypotenuse would be sine. So if we're given the opposite side and the hypotenuse, we're using sine. If we're given the adjacent side of the hypotenuse, we're using cosine. Now to finish this off, well, we just need to find out what because we just need to type 14 cosine of 26 into the calculator and get 12.6. Cosine of 12.58, but again, since we're going to the nearest tenth, the number after the 5 is an 8, so we round up. Now, let's see here. One thing that we do need to make sure that is on the calculator is this right here. Degrees. DEG is standing for degrees. Because if this is not DEG, the other one that it can be is, which is radians. And radians and degrees are not the same thing. So the way we can change it is under mode, because up at the very top, DEG, because if I go over and select enter here, it is now in radians. So I can quit. Now if we did the previous problem again, because we already know what the answer is, 12.58. So as we can see here, having it in radians instead of degrees will change the answer completely. Okay? Huh? Because radians in terms of pi, not 0 to 360. For these here, because all of our angles are given in degrees. If we were given it in radians, we need the calculator in radians. Pi. Because 30 degrees is, well, 90 degrees is pi over 2. 360 is 2 pi. Any questions on how we found x and y for this here? Let's look at the next one. So we're wanting to find the values of u and t. Now if I wanted to find the value of u first, so we're going to find the value of u first, would we use sine or cosine? So why would we say cosine? Yes. It is adjacent to 65. So we would have u over 8. Yes. And after we set it up, we're going to multiply by 8 so that we get the variable by itself. So that'll tell us that we have 8 cosine of 65 is equal to u. Now at this point here, we just need to type in 8 cosine of 65 into the calculator. 8 cosine of 65. So 3.38, which would turn into 3.4. So the value of u is 3.4. Now sine of 65 degrees would be what over what? Because it's opposite over the hypotenuse. The side opposite the 65 degrees is t, so we would have t in the numerator, and 8 is still the hypotenuse. So what would we do first? Multiply both sides by 8. T. Yes. And we would get 7.3. And that's about what we would expect, because the hypotenuse is 8, yes? The hypotenuse is always the biggest side length. It's opposite 90, so it's always going to be the biggest side length. So we know that u and t cannot be greater than 8, because 8 is always going to be the biggest side. We found u first at 3.4. And we know that this angle down here has to be less than 65, because 65 and this angle down here do add together to be 90. They all three add together to be 180. And it actually works out to be 25. So u has to be the smallest side length. T has to be between the two. So it makes sense that t ended up being bigger than 3.4 and less than 8. Questions on this here? Be ready for the next one. Find your answers and round to the nearest tenth. So we know x and y cannot be greater than what? 53, because it's the hypotenuse. Cosine of what? 35 is equal to y over 53. Because y is the adjacent side to that angle, and 53 is the hypotenuse. Then what would we do next? Multiply both sides by 53. Which will tell us that y is equal to, because these 53s will cancel, 53 cosine of 35. And again, at this point here, we just type this straight into the calculator. Now we need to find the value of x. So we're going to say sine of 35, because that's the angle they gave us, is equal to what over what? X over 53, because x is the side opposite the 35 degrees. We'll multiply both sides by 53. And the 53 and 53 over here will cancel, telling us that x is equal to 53 sine of 35. And that's it. Questions on this here? I put a good number of these in here so that we can make sure, I can make sure that you do have a grasp of how this works. Okay, so we're on this one here, yes? What's different about this one? There is a hypotenuse length, but it didn't give it to us, because in all the previous one, it gave us the hypotenuse, yes? But what value did it give us? Which one did it skip? Oh, those are just out of order then. Yep. Because that should be, yep. Because those are later on. That page got ahead. I'll have to reorder them when I ran the prints. So this isn't tangent. We could technically use tangent for this, but we haven't gone over it yet. Because what is tangent of an angle is equal to what over what? Do we know? It would be, yes. And we could use it for this one here. But 20, how does 20 and the angle 30 relate to each other? They're what? Opposite. So I can use cosine of 30 degrees because it's equal to, or not cosine, because cosine is what over what? Adjacent over the hypotenuse. So this would actually be sine of 30 degrees. Because sine is opposite over the hypotenuse. We're just missing 2 at the moment for talent search.
That poor Angel, she's in here with all of the speakers.
Well, so looking at this here, sine is opposite over the hypotenuse. So what's the opposite side length? And the hypotenuse is? We can't reverse it, but we can do it the other direction, because I could find this angle down here, which is 60, but that would be cosine of 60 is 20 over hypotenuse, which we don't have. So in either case, the hypotenuse still ends up in the denominator. Now what we do for this here really isn't any different than what we did on the previous ones. Because in all the previous ones, we multiplied both sides by the hypotenuse's length. So here, we're going to multiply both sides by y. Multiply both sides by y. Because just like before, this value of y and this value of y will cancel, telling me that y, sine of 30 degrees, is equal to 20. Now, is y by itself? So how can I get it by itself? Both sides, well, is 20 and y, are they next to each other? So what's connected with the y right now? Sine of 30. So I can divide both sides by sine of 30 degrees, because really sine of 30 degrees is just a number, isn't it? So really just dividing by a number. So these here will cancel out, simplify out, telling us that y is equal to 20 divided by sine of 30. So in the calculator, we can hit our fraction key and go 20 over sine of 30 and hit enter. It tells us that it's 40 degrees. So y is 40. No. It can be a decimal. Because here, the values of sine and cosine that we've seen all the way up so far, have any of them really been whole numbers? No, there's the cosine of 30 was 1/2. So there are a few that do work out to be nicer numbers. Sine of 30 works out to be 1/2. For sine of 30. We can, yes. So I'm going to erase this here so I have room. So if we have found that angle, we can say that sine of 60 degrees is equal to what over what? X over, guys, x over 40. And then we would multiply both sides by 40. Which would tell us that x is equal to 40 sine of 60, which is equal to Wait a minute, this is 30, 60, 90, right triangle. Yep. But we also have really identified now with sine and cosine, proven that that still holds true. What we could have also done instead of using sine is we could have done this using cosine of 30 is equal to the adjacent side length x over the hypotenuse. And we can multiply both sides by 40, telling us that x is equal to 40 cosine of 30, which is 20 square root of 3. Questions on this here? Let's look at another one. Yes, because with sine and cosine, we need the hypotenuse. No matter how we set this up, we need the hypotenuse's length. So let's do sine of 51 and see what we get. So sine of 51 is what over what? Opposite over the hypotenuse. So the opposite side would be y, and the hypotenuse is x. So we're stuck, yes? Because we have two variables. Okay, well let's do the other one. Cosine of 51 is 10 over x, because it's adjacent over the, multiply by x. And in all these here, really, the first step is we multiply by the denominator. So we get cosine of 51 times x is equal to 10. And after we multiply both sides by the denominator, we need to see, is the variable by itself? Well, here, it's not, because it's connected with the cosine of 51, yes? So we need to divide both sides by cosine of 51 degrees, which these would cancel, telling us x is equal to yes. Yeah, otherwise we're not able to really write the full decimal because it's not a nice number for most of them. There are a few that do work out nicely, but for the most part they don't. Now we can use sine also because we don't know why, but I do know x is 15.9. Will we get the exact value of y? No, because what did we do for x? We had to round. So we can get close to the value of y, but we won't get the exact one because we didn't get the exact value of x. And that's fine. But we'll still do the same process because we're going to multiply both sides by 15.9. If we do that, these two cancel, telling me that y is equal to 15.9 times sine of is the variable by itself. If you want to plug it in. Is that the value we expect? Well, yes. Because the hypotenuse x is still the biggest value because it got the biggest number. We know that these two angles will add together to be 90. This one is going to be smaller. It's actually 39, making 10 the smallest side, 12.1 the middle, and the hypotenuse still the biggest. Questions on this here? Any other questions on anything we've done here? Do we feel good with these here? Now, one of the biggest things I will say, especially on the homework, because it's going to be a worksheet, it's not going to ask, most of them are not going to ask for all three sides. The homework sheets is not going to ask for all three sides. It's going to ask you to find one of the sides. And the one side that you're trying to find, sure, okay, is all you need. You don't have to find the other. So depending on the setup, we might need to use sine or we might need to use cosine. We're going to have to use one or the other. You could do both like we've been doing, but if it's only asking for x and we would just use cosine. Because to use sine, well, I would need to find x and then find y, or vice versa. So there's only one that we need to use. You're not asked to find both. Okay. And that's it. And we could use these with angles of depression or kind of triangles like this here to find missing side lengths. Let's see here. We'll look at this one here because we do have ample amount of time. You are skiing on a mountain with an altitude of 12,000 feet. The angle of depression is 21 degrees. From the skiing distance of the mountain to the nearest foot, how far are you going? So when we talk about angle of depression, it's essentially if we drew a line at eye side, going straight out at eye level, it's the degree from that line going down is angle of depression. This here, this angle right here, is what we call the angle of what? Well, depression's up there. We're going what? Up, so we call it an elevation. Elevation, so it's the angle of elevation. Because looking up is the angle of elevation, looking down is the angle of depression, and what works out interestingly enough is that the angle of depression and angle of elevation are congruent. They're actually going to be the same because these lines here parallel to each other. Well, but we still have a triangle right here. And we know the opposite side length, so we can say sine of 21 degrees is equal to opposite over x. Multiply both sides by x. Well, the variable's not by itself, so we need to divide both sides by. And x is what? 33.48. And that makes sense because it is the hypotenuse, so we expect it to be the longest side length. And that's it. You have this worksheet here, which is a staggering 12 problems. Now, these here, so you're going to round to 4 decimal places or 1. Just go 4 decimal places, just because that's what the instructions say. I don't know why the person who made that said 4, but yep. So on all of them, you're just finding x. Yeah, because it's only asking for one variable. It's just asking you to find the value of x.